In this video, we'll go over some symbols you may not be very familiar with or you may not be entirely certain about. The first symbol is a letter like the letter X. We use the letter X, Y, and Z and others to denote variables. So X can be any variable that we're working with. And when we collect data on that variable and have specific values for it, then those are indicated with the letter that signifies the variable plus an index. So x1 would be the first data point on variable x, or the first measurement on variable x. x2 would be the second, x3 would be the third, and so on. So these 5 things on the screen are 5 data points, 5 measurements of variable x. The next symbol that is useful in this context is the symbol of summation. This scary looking thing is actually a capital Greek letter, sigma, and it actually means to sum, summation. And the thing that we will see most of the time is something like this. This is beginning to look even scarier, so it is useful to try and parse these components and realize that it is actually a very simple and easy shorthand to display things that could otherwise get very long. So the first thing to notice is that there is the letter I, and the letter I appears here and also appears here. And then if you look above and below the sigma symbol, you see that there is also a number or some value down here and some value up here. Now it turns out the first value is actually the number 1, and the symbol up here is an unknown value. It's n. It could be anything. We just need to know what it is in a given context. So whatever n is. So what does all of this mean? Well, the idea is that I, which is our index, which is the same as this one. So our index takes on different values in sequence. So it starts with the value shown here. So the first thing that this means is that I would be equal to 1. And then the next thing would be that I would be equal to 2. So I would take sequential values all the way up to n, however many that is. So if n is 5, I would first be 1, then it would be 2, then it would be 3, then it would be 4, and then it would be 5. And for each value of I, then we have whatever is after the sigma symbol. So for I equals 1, we get x1. This thing becomes whatever I is at this point. And when I equals 2, we get x2. So this becomes whatever this is at this point. And for I equals 3, we get x3, and whatever for the next steps until the last one, which would be xn. So this is the first value of x. Therefore, this is the second value of x, this is the third value of x, and this is the nth, the final value of x, of our x variable. And we're not done yet because we haven't yet used the summation. So we actually have to add these. So what this means is that this whole thing is exactly the same as this. We use this as a shorthand instead of writing all of these. So in the case where n equals 5, I would go from 1 to 5, and so the sum of xi for I equals 1 to 5 is x1 plus x2 plus x3 plus x4 plus x5. Instead of writing all of this, we write this. So we save some space. And When we're not sure what n will be in any given instance, we just use this as a shorthand in a more abstract sense to mean however many they are, we just add them up. So this kind of formula appears when we have the mean. You already know that the mean is the sum of all the measured values divided over how many they are. So it's x1 plus x2 plus x3 plus however many we have plus until the last one divided by n. So you see the use of an unknown number to mean as many as we have. Instead of writing all of this, because n could be very large, and then this would get very long, we just say and write this, which is exactly the same thing. So the sum of xi for I equals 1 through n divided over n. And these two things are the same. And actually, you'll see in books, to save printing space, they don't write I equals 1 to n below and above sigma. Sometimes they print it like this, which is exactly the same thing. So they save a bit of vertical space on the page, and this can go within one line. You'll see this in books very often. It means exactly the same thing. And so this is our mean. And as you've probably seen in books, this is how we represent the mean with a symbol. And this is a thing that is very general symbol. This little horizontal line above the variable name means the mean value of all the measures that we have for this variable. So x bar, which is how this is pronounced, means the mean value of x. And by now you will have noticed that there's a bunch of symbols that we use to represent the mean, unfortunately. So in some books you see lowercase x bar. In other books you'll see capital X bar. In other places you'll see lowercase m. In many papers that follow, especially papers that follow the APA format, you'll see capital M. And in some places, including some previous videos here, you'll see the lowercase letter mu. It turns out almost all of these are the same thing. So all of these symbols are used in different contexts to indicate the mean of a set of values that we actually have, which is called the sample mean. In contrast, this symbol, the Greek letter mu, lowercase Greek mu, refers to the population mean, which we usually don't know. So it's still a mean value, but it's a mean value of everyone, including those who haven't measured. So to be formally correct, when we have a sample, when we measure some people on a variable, the mean value of our observations would be x bar. And if we were writing a paper or reading about them in a paper, we would most likely see that referred as capital M. But if we wanted to refer to the mean of the population, so the mean of everyone, including those we didn't measure, so every human or every Norwegian or every student or every child, that would be the population mean mu. And we've used a sample of the population, hoping to get an estimate for that. We'll get more about that. The idea here is we have different symbols, some of which mean the same thing and some of which don't. Now, to go back to this way of writing things, the sigma symbol of summation, you aren't restricted to just a simple expression like this. So the sum of xi, which is exactly this thing, could be the sum of something more complex in other situations. So you can use this symbol, for example, to mean like that. So the sum of all the differences of xi minus x bar for I equals 1 to n. Now, I realize this may look a bit scary at first glance, but it's no more complicated than we had before. To parse this, you just have to go step by step and think what is going on here. So this means that we first have x1 minus the mean of all the x's, and that's here. And then we have x2 minus the mean of all the x's, that's here. And then x3 minus the mean, and then so on until the last x minus the mean. And then we just add them all up because of the sigma. So all of these take on their sequential values. Whenever you see I, you replace whatever value I has at the moment. You write all these down and then you add them up. Well, in fact, you never actually go and do this by hand. The computer does it for us, but this means this. And it can get even more complex if you want to add another operation. So if you want every difference to be multiplied by itself, then you just add it here. And then it means that you have to do it in each case before you add them up. So this is a very general and very useful symbol to indicate summation of sequences that can become very long. And oftentimes you can use this symbol when we don't know exactly how many they are, to indicate a general principle, like for example in the mean, where we just have to add up however many samples we have.